Okay, this little video is on calculating 3x3 determinants, not using the rule of Saris, but using minor determinants and cofactors. So let's look at an example. We have a 3x3 determinant, and I'll just throw out some numbers at random here. 2, 1, 0, negative 2, 5, 2, 3, 7, 1. And our task is to determine the value of this determinant. But we're not going to be using the rule of Saris, but rather minors and cofactors. Okay, so we can pick any row or any column to expand about. I'm going to pick this middle row right here to expand about. And what this is going to work out to be, it's going to be these numbers times a power of negative 1. So negative 2 times negative 1 to some power, times a little 2x2 determinant, okay? And then we'll do 5 times negative 1 raised to a power, and we'll figure out what that power is in just a minute, times its little 2x2 determinant. So for these 2x2s, right, we're going to have to come up with these 4 numbers. Okay, and then 2 times a power of negative 1 times its little 2x2. So again, the task here is if we can figure out these minor determinants, these small 2x2 determinants, and then figure out what power of 1 goes in there. This is pretty straightforward because 2x2s are easy to calculate. Okay, first of all, the power of negative 1 here. For each element, it's in a row and it's in a column. This is in the second row, first column. So we use 2 plus 1, which is 3. This is in the second row, second column. So we do 2 plus 2, that's going to be 4. And this is in the second row, third column. So we're going to use 2 plus 3, and that's 5. Okay, so once we figure out those powers of negative 1, this is pretty easy. Negative 1 cubed is negative 1. We have a negative 2 times negative 1 times negative 2. This is just going to be 2. Okay, here we have negative 1 to the 4th. Well, negative 1 to the 4th is a positive 1. Positive 1 times 5 is just 1. And here we have negative 1 to the 5th. That's a negative 1. Negative 1 times 2 will be a negative 2. Okay, so we take care of that. Now, for the minors, if we look at just this first element, remember this is the minor that went with the negative 2. What we effectively do is we imagine crossing out this column and this row. So the first row and the first column are just marked off, and we look at the numbers that are left, 1, 0, 7, 1, and that's what goes here, 1, 7, 0, 1. So we have 2 times that determinant. For the second minor, that came from the 5. Again, we're going to mark off this row, but now we're going to mark off the first column. So we're going to take away this column, if we will. I'm not going to cross them out because I want to see the numbers. And the numbers that we have left are the 2, 0, 3, 1. And that's what goes over here, 2, 0, 3, 1. And for the last one, that was coming from this number, right? We're going to mark off this row and the third column. I'll mark these off. And we get what? 2, 1, 3, 7. And that's what goes in this slide. 2, 1, 3, 7. So it takes a little bit of figuring out to set up the expansion. But once you've done that, that's pretty straightforward. So if I just clean this up a little bit, let's see, I have 2 times this determinant, 1, 7, 0, 1. Plus 5 times this determinant, 2, 0, 3, 1, and then minus 2 times this determinant, 2, 1, 3, 7. I'm just trying to put them all in one line there. And again, each of these 2x2s are trivial, right? So let's see. This is, remember how to do a 2x2. We multiply, we subtract. So 1 minus 0 is 1. So that's 2 times 1. This is 2 minus 0, which is 2. So 5 times 2 is 10. And this is 14 minus 3, which is 11, right? So 14 minus 3 is 11, and negative 2 times 11 is minus 22. So what do we have here? We've got 12 take away 22 minus 10. That's the value of this determinant. So if we were to do this by rule of Saurus, and you might want to try that on your own, do it with rule of Saurus, then you should get minus 10. Now, the intriguing thing about using minors and cofactors, it doesn't really matter which row or which column you expand about. I expanded about this middle row just because I wanted to. Let me expand about this first row and watch what happens. The 0 is going to be our friend here. So setting up our expansion, we're going to have 2 times its little minor determinant. Now we're crossing off that row, that column, and there we are. So 5, 2, 7, 1. Now, you say, well, wait a minute, how about the power of -1? Yeah, I did that in my head. This is first row, first column, so there's going to be -1 to the second power, which is just a +1. So there is a +1 there. I didn't have to write that. Okay, plus 1 times its little 2 by 2. Let's see, cross off this row, this column, I get these numbers. So -2, 2, 3, and 1. How about the power of -1? Well, let's see. This would be -1. This is first row, -1 cubed. Well, that should be a negative. Let me change that. And then for the last one, I'm going to have 0 times its minor. But it's 0 times, who cares? It doesn't matter what this is, and it doesn't matter about the power of -1 because we're multiplying by 0. So this bit just goes away. So really by using this first row, I only have 2 by 2s to do. I've lost something here. Let's see, 5, 2, that should be a 7. And I didn't write my 7. Okay, so let's just double check. We know the answer is supposed to be -10. This is 5, take away 14. 5, take away 14 is -9, times 2 is -18. And this is -2, take away 6 is -8. There's a -1, so that's +8, and that's -10. Okay, I'll give you an application of this in finding cross products in the next little video. Okay.